Alright guys, so now we are going to work with the problem number 7, where we need to graph the y equal negative sinus x. Problem number 7. So let's try to first realize that basically y is equal to negative a function f of x, and this function f of x is equal to sinus x. And let's try to graph sinus x first. So if I want to graph sinus x, I must remember a few things. First of all, you must remember that I'm going to try to do this like this. There we go. You are reading, and hopefully, all right. And this way, like that. All right. So I'd like to remember that you will read the value of the sinus on the vertical axis. You know that your sinus will be equal to 1 and negative 1, and you know that your cosinus will be reading on the horizontal axis between 1 and negative 1 also. So the first thing you try to do is try to define for which value of x the value of sinus will be equal to 0. X is an angle. So you are going to do is pretty simple. When the angle equals 0, f of x equals sinus 0. Let's write f of 0 equal sinus 0, and sinus 0 equals 0. Because when x equals 0, when the angle equals 0, you are right here, and the sinus is 0. Now, let's continue. When x equals pi over 2, I know that f of pi over 2, which is sinus pi over 2, I will be equal to 1. So on my graph, basically what I have, okay, right? On my graph, what do I have? On my graph, when x and my graph is directly connected to x, okay, when x equals 0, sinus, I will have right there the value of sinus x, and sinus 0 equals 0, so I'm right here. When x equals pi over 2, so let's define that this distance right here corresponds to pi over 2. I know that I'm supposed to be at 1, so let's figure it out. That will be equal to 1. When x equals pi, the value of f of pi will be sinus pi, and sinus pi is equal to 0 also. When I am at sinus pi, pi is right here, and the sinus is again equal to 0. I would like to remind you that the sinus is not equal to 0 when I'm right there. This is where you are going to read the value of your cosinus, and this is where you are going to read the value of your sinus. When your angle is equal pi, the value of your sinus is equal to 0. Okay? Therefore, right here, we are at x equal pi. So now it's pretty simple to imagine that if I wanted to, what I could do is I'm going to use my ruler again, make it bigger. There we go. And now, if I go to 3 pi over 2, well, now it's going to be minus 1. My sinus will be equal to minus 1. And when I add at 4 pi over 2, which is 2 pi, I'm back at 0. So what do I see? Is I see something going like that. Okay, this is sine x. Well, remember what we're trying to find is f of x equal minus sine of x, and that means now pretty easily that we have a reflection, and so we end up to have something like that, and this is f of x equal minus. Now let's try to see the difference with the what we call the amplitude and the period. All right, so let's try to do the problem number 9. On the problem number 9, what do we have? So problem number 9. On the problem number 9, we need to find, and I'm going to use the blue, so this time, y equal sinus 2x. So to graph that, it's going to be the same idea. First, I'm going to consider 2x as an angle. Okay, 2x is the angle. And then what I'm going to do is I'm going to say, okay, 2x equals 0. Well, sinus 2x will be equal to 0. Okay, when 2x equals 0, sinus 2x will be equal to 0. By the way, 2x equals 0 means x equals 0 over 2. So I'm still with x equals 0. Then, when 2x equals pi over 2, remember, sinus of an angle. So what is the value of the sinus when the angle equals pi over 2? Which means in that case, x equals pi over 4. Well, sinus 2x equals 1. So when x equals pi over 4, I'm getting sinus 2x equal 1. When x equals 0, I'm getting sinus 2x equals 0. Alright? I could continue forever by saying if 2x equal pi, well, that means x equal pi over 2, sinus 2x will be equal to 0. Okay? So if you don't mind, what I'm going to do is I'm going to go back to this first graph right here. When x equals 0, I'm right here. When x equals pi over 4, so obviously pi over 4 is right there. When x equals pi over 4, I said that the sinus 2x equal 1. So now my 1 is right there. When x equals pi over 2, sinus 2x equals 0. So now my 0 is right here. And you understand now that I'm moving pi over 4 to pi over 4. When 3 pi over 4, it will be negative 1. Pi, it will be 0. And so basically, what I have is something like this. I could continue forever, okay? I could be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, I would be at 1. So I could continue like this and going down, okay, and be at 1 right there, etc., etc., etc. So it is very interesting for you to see, and let me write right here 5 pi over 4 to help you, as well right here as 3 pi over 4. So it is very interesting to see what is the difference between the red one, which is sinus x, and sinus 2x, and the effect of multiplying by 2 the x. All right, so let's continue and let's try to do the problem number 12. All right, so to do the problem number 12, now this time, problem number 12, we're talking about graphing y equal 2 cos x. So first, what I'm going to do is graph y equal cosinus x. And then I'm going to use the same tactic. The first thing that I want to do is say when x equals 0, when the angle is equal to 0, I consider x as an angle. When x equals 0, well, what is the value of your cosinus? Well, remember, where we are reading the value of cosinus. When x equals 0, I'm reading the cosinus on the horizontal. All right, this is where I'm reading the value of my cosinus. So when x equals 0, the cosinus equals 1. So when x equals 0, cosinus x equal 1. When x equal pi over 2, cosinus x equals 0. When x equal pi, cosinus x equal negative 1. So let's try to graph that, shall we? All right. And all right. So we are going to read right there y equal cosinus x. And this is where we're having x, the angle, okay? When x equals 0, we said that, and let me use the same color. I'm going to use the color red for the cosinus, like I used for the sinus. So when x equals 0, we said cosinus equal 1. Let's define this as 1. When x equal pi over 2, so let's define this distance right there, pi over 2. I know that cosinus equals 0, so I'm right here. When x equal pi, obviously the double distance that I have right here, if that is pi over 2, obviously this is another pi over 2, so we end up to be at pi right here. Okay. We are at negative 1. 1, 2, negative 1. I'm right here. So at 3 pi over 2, I'm at 0. And at 4 pi over 2, which is 2 pi, I'm back again at 1. So my graph is something like this. Let me see if I can do that better for this one. There we go. There we go. Okay, so that is for cosinus x. Now, if I have 2 cosinus x, okay, let's try to work on y equal 2 cosinus x. Well, remember what we said. When x equals 0, we said cosinus x equal 1. But 2 cosinus x, it's equal to 2 times 1, which is 2. When x equal pi over 2, we said that cosinus x equals 0. Well, 2 cosinus x is not going to change. It will be equal to 0. On the other hand, when x equal pi, cosinus x is equal to negative 1, and 2 cosinus x, it's equal to negative 2. So guys, now I'm let you draw the picture. You got everything you need.